What are the most important parts of a telephone? What combination of electrical circuits and mechanical devices allow two people who are miles apart to talk as if they were in the same room? You will see in this film how three fundamental systems use six basic components in the creation and regulation of the vital currents in the telephone line. You will see how the sound-powered system, the local battery system, and the common battery system utilize generators, ringers, transmitters, receivers, induction coils, and capacitors to carry the sound of our voice over two simple wires. Actually, our line forms a closed circuit through terminating points, connecting two stations on a point-to-point line. Before station 1 can talk to station 2, he must signal for his attention. The telephone generator is used for this purpose. Let's see how the generator employs the principle of magnetic induction in the creation of voltage to operate a suitable signaling device. This represents a piece of wire which we will move through the lines of force created by a permanent magnet. When a wire is moved through lines of force, a potential is induced in the wire which alternates as the wire is moved in or out. We can increase this potential by speeding the motion of the wire through the flux field created by the magnet. Rotational movement of the wire in the field of flux will also increase the potential in the wire. As the rotational speed is increased, the potential in the wire is increased still further. If we also concentrate the magnetic field by bringing the north and south poles of a magnet closer, and either increase the speed of breaking the magnetic field or increase the number of wires rotating across the lines of force, we will have a generator. Some generator magnets are located within a coil. Each time the magnetic lines of force of the magnet rotate across the wires in the coil, a potential is induced. Because of the difference in polarity of the magnetic poles, the induced voltage is alternately negative and positive. When we connect this generator to our line, it will create a signaling current alternating at approximately 20 cycles per second. Let's take a closer look at the electron flow in one of the lines. It shows that we have created a signaling current which will operate a visual or audible device to attract attention to the telephone. The audible device is the telephone ringer, or buzzer. The telephone ringer works on the principle of electromagnetic attraction and repulsion. When two soft iron cores are wound oppositely with wire, they become electromagnets whose polarity will change as the current in our line alternates. If we introduce a soft iron armature near the base of an electromagnet, and then introduce a permanent magnet to polarize the ends of the armature, an unstable condition will exist when current flows. When a signal is sent over our line, the polarity of our electromagnet will alternately attract and repel the ends of the armature operating the clapper rod, which alternately strikes each gong. Here we see an actual telephone ringer in operation. Another audible signaling device is the telephone buzzer. This device uses a bar magnet, an electromagnet, an armature, a non-magnetic separator, a stabilizing spring, a clapper rod, a diaphragm, and a single wire coil. As the current changes in the wire, the polarity of the electromagnet changes. As the polarity of the electromagnet changes, it attracts or repels the armature to the core. Here is an actual telephone buzzer in operation. A complete ringing circuit allows each station to call the other and provides a switch for disconnecting the ringer. As the generator is turned, the switch connected to the ringer is opened. This places the generator across the line. The same thing happens in the opposite direction. How does the generator switch operate? A rotary action exerts a centrifugal force on the counterweights in the generator. As the counterweights are spread apart, a movable button drops down and makes contact with and closes the generator circuit. As the counterweights come together, the button raises and makes contact with and places the ringer on the line. This is how the generator switch works in the circuit. The miracle of the telephone is that when once signaled, two stations can talk to each other in normal tones over virtually limitless distances. To accomplish this, the telephone transmitter converts the sound waves of the sender's voice into electrical waves for transmission over wires. At the other end of the line, a receiver reconverts the electrical waves into audible sound. The secret of the telephone lies in this ability to interchange sound and electrical waves without changing their forms. For the initial transformation of sound waves into electrical waves, the sound-powered transmitter employs the same principle of magnetic induction used in the generator. In the transmitter, a permanent magnetic field is set up across two pairs of poles. To provide the lines of force with an easier path than through air, a soft iron armature is used to shunt the magnetic field across the poles. When the armature pivots, the direction of the field through the armature reverses itself, flowing always from north to south. The armature is surrounded by a coil. As the polarity of the armature changes, it induces an alternating potential in the wire. By attaching a connecting rod from the armature to a diaphragm, similar to that found in a telephone transmitter, a direct linkage is effected. The energy of sound waves moves the diaphragm. Because of the direct linkage, any movement of the diaphragm is transferred to the armature. This means that an alternating potential will be induced in our coil, which exactly corresponds to the wave pattern of the sound waves. This is the way we transform sound waves into an alternating current capable of carrying speech several miles over a line. At the other end of the line, a device similar to the transmitter reconverts the electrical current into audible sound. The telephone receiver, however, employs the principle of electromagnetic attraction and repulsion used in the operation of the ringer. As the voice current in the coil alternates, the polarity of the armature reverses, causing each end to be alternately attracted or repelled by the permanent field magnet. Consequently, the diaphragm pushes out audible sound waves exactly mirroring the waves of the original sound. Since the transmitter and the receiver are virtually the same in design, they can each do the other's job.
Say, Bud, did you take a shower this morning?
A shower? No. Is one missing?
Funny, funny.
For convenience, a second unit is placed in parallel across the line, giving us the simplest of all telephone systems, the sound-powered system, so called because it draws its energy directly from the transmitted sound. The chief advantage of the sound-powered system is also its biggest limitation. If, for instance, our line is extended beyond a certain range, the received signal will fade out and become unintelligible. The resistance in our line becomes too great to be overcome by the weak energy of the sound-powered transmitter. If we wish to talk over longer distances, we must use another telephone system, one which draws its power not from the weak energy of sound waves, but from the powerful charge of a battery, the local battery system. Now, instead of using a sound-powered device to generate an alternating current, we will use a carbon transmitter to vary the release of direct current from a battery. Sound waves striking the diaphragm compress loose carbon granules in the carbon transmitter. This lessens their resistance and allows more electrons to flow in the circuit. Our voice is therefore carried by a pulsating direct current pushed by the strength of our battery. At the receiving end, if the line resistance is increased, it will reduce our signal strength and thus limit our acceptable transmission range. The solution is to insert an induction coil, which is simply a soft iron core around which are wrapped two wires, a primary and secondary winding. This removes both transmitter and battery from our circuit, and at the same time induces a higher AC voltage in the secondary winding connected to the line. Sound waves varying the electron flow in the transmitter circuit cause the field of both the primary and secondary windings to expand or collapse. As the magnetic field of the primary cuts the windings of the secondary, an alternating voltage is induced into the secondary winding. Because this winding contains more turns than the primary, an increase in voltage occurs, represented by the larger polarity signs. This will permit transmission over longer distances. Since our power will continue to drain even when we are not talking, our battery life can be prolonged by inserting a press-to-talk switch in the transmitter circuit. By adding a receiver, we are ready to talk, alternately receiving or sending. We can hear ourselves in our own receiver through an effect known as side tone. If we listen with our press-to-talk switch closed, the incoming voice will be interfered with by background noises coming from our own transmitter. Our ringing circuit allows station 2 to signal station 1, and vice versa. And our talking circuit allows station 1 to talk to station 2. And vice versa. But there is something missing in this circuit, because when station 2 rings station 1, the current in our receiver circuit overloads the receiver. The same thing occurs when station 1 signals station 2. To correct this, we must make use of our sixth basic component, a capacitor. Certain capacitors impede low-frequency ringing currents that could enter the receiver circuit, yet pass high-frequency voice currents. Our local battery system is ready for traffic in either direction. The local battery telephone has a much greater transmission range than the sound-powered telephone. In a field telephone, the transmitter, receiver, and press-to-talk switch are combined into a convenient handset. The induction coil, capacitor, generator, battery, and buzzer are contained in a waterproof housing. Not only two, but many stations can be interconnected, one way or another, by use of a switchboard. First, let's consider the local battery switchboard. We can simplify our wire stringing by bringing only one line from a telephone to a central location and terminating it on a switchboard. Here, plugs and jacks are provided, allowing an operator to connect each station with any other station. A visual indicator allows a station desiring service to attract the operator's attention. The operator's pack contains a headset consisting of a transmitter, receiver, cord, and plug for talking and listening to stations. The operator also has a generator for ringing. Here's what happens when one station calls another through this switchboard.
Dagger switchboard.
Dagger 3.
Dagger 3. Dagger 3.
Dagger 5.
And the conversation proceeds. Note that with this local battery switchboard, Dagger 5 had to call the operator with his own hand generator. When the conversation is finished, he must again signal the operator to disconnect. We can facilitate the handling of calls even further by using a common battery switchboard. This system provides for automatic rather than manual signaling, eliminates local batteries, and provides faster service through more efficient operation. Generators and batteries are eliminated at the local stations, and the switchboard provides all power for both signaling and talking. Each station terminating on the common battery switchboard has its own jack and line lamp. The operator's key shelf is provided with a battery source and contains a generator, an answering cord, a supervisory lamp, a calling cord, and a supervisory lamp which signals when the receiver is replaced on the hook. The operator is provided with a key which, in one position, allows him to talk on the line, and in the other position allows him to mechanically ring any station on his board. Now we will see how much easier it is to place a call over this system. The operator is automatically signaled the moment a station takes the receiver off the hook. At the same time, the hook switch puts the battery in the transmitter circuit, making it ready for talking.
Number, please.
Dagger 3.
Dagger 3.
Since the supervisory lights go on when the receiver is down on any connected line, the operator is automatically informed when the called station answers.
Dagger 3.
Dagger 5.
Notice that when each station hangs up at the end of the call, the operator is automatically signaled to disconnect. Let's review the three basic telephone systems. The sound-powered system uses generators, ringers, capacitors, receivers, and sound-powered transmitters. If necessary, a switchboard can be used to handle many stations. The local battery system uses generators, ringers, capacitors, and receivers, but uses carbon transmitters instead of sound-powered transmitters. In addition, it uses induction coils and draws its energy from batteries at the individual stations. This system, too, may or may not use a switchboard. The common battery system, however, must use a switchboard, providing power for both signaling and talking. Ringers, capacitors, receivers, carbon transmitters, and induction coils are again used at each station. Beyond these three simple systems lie the ever more complicated wonders of modern telephony. Yet all these systems rely on the 6 basic components found in the telephone. They are generators, ringers, transmitters, receivers, induction coils, and capacitors. All of the 3 basic telephone systems depend upon our line, which must be properly engineered for the telephone system to be used.